and gravity converge, yeah, guiding voices, revelation start. Ancient whispers call, they're begging us to open our eyes. We stand tall, defying all their lies. Even in now, we're shattering the silence. Feel the power, revelations on the rise. Forbidden knowledge we dare to see, unveiling secrets, setting us free. In this epic we play our part with fierce hearts. In and now, we're shattering the silence. Feel the power, revelations on the rise.
In base lab alone with my mind, stable theories they all refuse to find. I've been working on energy for a brand new day, but even in the crowd I'm still been cast away. Alienated from the aids of added nature in disguise. Ideas ahead of time dismissed with narrow eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Talking love 0 point, the points lost on them. Kevin structures crumbling from the same old Sam. They laugh like I'm crazy, but I see it all so clear. Exploited labor, unheard injustice, burning ears. Fighting for a change in this wasteland of noise, but they call me foolish when I teach and boys. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Chasing revolutions in the darkest nights. A dreamer with vision beneath the laughter and noise. A future so bright waiting for the right choice. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice?
In a lab, my dust cracks the code tonight. Oh yeah, that's true. Wires and circuits that shine in neon light. Oh yeah, seen you creating power from the air. These smiles and delight. Oh yeah. Mike does it right. Hey. Mike does all my keys to one. Teaching us knowledge, lighting the sun. Trumpeting his legacy alive is his. Mike does knows we're his beast. bands. Down in the basement, secrets start to glow. Oh yeah. With Nathan Lulu in the show. Oh, brilliant team. My K-pop parody. We're letting knowledge flow. Energy streams. Like that's all my keys to one. Teaching us knowledge, lighting the sun. Trumpeting his legacy alive is his. Mike does knows we're his biggest fans. Years of thought, bringing dreams to life, turning theories into electric light. Mike and us, a journey to ignite. We've reached new heights. Mike does all my keys to one. Teaching us knowledge, lighting the sun. Trumpeting his legacy alive is his. Mike does knows we're his biggest fans.
In a town down south where the fireflies glow, there's a man named Michael with a vision to show. Billy told to go, he's got the spark, dreaming of a future that'll light up the dark. But on the other side, Bill Nye's on the rise, because that old charts, he's got down all the lies. And it's just fixed, it's all in the map. You can't pull from the ether, you're just chasing a path. But oh, Michael's rising like a morning sun. With the power of either, he will be outdone. Now stand up and shout, let the truth be unfurled. Feel the energy flow, let's change the world. In the heart of the lab, the tension was thick. Skeptics gathered round the table ready to pick. Chose your fruit, fed neck, the taste beer, and I find the stream. You're just chasing a spin. But Michael smiled by with fire in his eyes. Just watch as I spin, let the naysayers cry. Girl, spin fast, and a heart full of fight. I'll show you the power that's hidden inside. Oh, Michael's rising like the morning sun. With the power of either, he will be outdone. Well, stand up and shout, let the truth be unfurled. Feel the energy flow, let's change the world. The best there's ever been.
Majestic moments in cosmic flight, holding on to the stars of starlight.
Hello, everyone, and welcome to the Builder's Workshop. My name is Nathan, otherwise known as Old Man Builds. We have the Benefactor here with us, and we have Sean, the Mad Coiler, here with us. Guys, how's it going?
It's going great. I love this live stream. I love hanging out with you guys in the chat. So thank you, Nathan.
What's going on, everybody?
Hey, Gerald's in the chat. What's up, Gerald?
What's going on, Gerald?
Gerald's the man.
Yeah, I can't wait till he finishes his stuff and comes back, man.
Oh, everybody's in anticipation to see his stuff.
Yeah, we miss you, Gerald.
Yeah.
We heart you, Gerald. Sorry for the clanking noise. I'm drinking tea for my cold. So I'm ready when you are, Nathan.
Yeah, absolutely. We add it to the stage, and I'll pull us out. It's all yours, Sean.
Sounds good. All right. Well, welcome everybody. It's great to see you in the chat. I always appreciate your guys' input into my presentations. And as you know, my presentations are just clips from my iPhone. But I appreciate you taking this journey with me as I perform experiments in the lab. It always seems that the coil is my theme, so I always have some kind of coil in the first pick. Now this is a little bit from last week. This was the sphere that I was able to get balanced. Excuse me. Sorry about that. This is from last week, and I talked about how it was able to produce such large plasmas, but one thing that was unique about it, or actually two, one was this coil was acting on top of the point here, was acting like a muffler, and forgive me. And the copper spheres were assisting the ground. So the bottom of this sphere was connected to the copper spheres on the ground. And that gave it not only a little bit fuller in the discharge, but it also sent discharges up to 18 inches. And that's pretty amazing. So this was the black coil that I'd spent some time on that I talked about last week. And it's about a third smaller, 2/3 smaller than it was when I had first wound it. And that's because there's an open wire somewhere in one of the grooves here. So about 10 to 12,000 turns of wire, and I can't get this coil working. So I started winding a new one. Again, this is not new. This is kind of a recap of last week, but I kind of wanted to talk a little bit more about the cone. So it's super easy to wind. If you put together some kind of winder, this is pretty inexpensive. I got it from Amazon, and I think it's under $50, and it has a counter on it, which I don't use, but I probably recommend using. And so this is the filament that is the translucent PETG, which is a lot more finicky than your normal PLA. And the spool of wire is 32 gauge magnet wire. 32, 33, and 34 gauge wire are the best that I've found out in winding these coils. The thinner the wire, the higher the voltage. So if you're going to wind a smaller coil, then you use the smaller wire, and you can get the same effects as if you had a bigger coil and bigger wire. And I showed this again. It's a work of art. Now, this is the cone in action, and here I'm trying to get the right signal, and I still haven't figured out how to get this to resonate at its resonant frequency. But you can kind of see that's the lousy version. This is a bit better. So if you'll notice here, the sine wave that's linear, it's straight here, is very different than this wave that starts as a straight line and then starts to wiggle up and down more and more. Now, if this was resonating completely, then you would see the inner secondary sine wave coming up to the top and getting real big. This just sort of peters out. There's a reason kind of for this recap. So if you look at how thick the bottom is of the cone, this was kind of on purpose. I just wanted to have a good, strong, thick base. But I think because I have this thick base, that this is why I'm getting the high capacitance. When I take capacitance readings on this coil, it measures to 2 microfarads, which is quite large. We always are usually working in the nanofarads, and I haven't really used a coil that's used up more than maybe 750 nanofarads. So this here equals 2 microfarads, and so that's just good to know. So here's it comes out. It's a bit messy. It's a bit rough. And I picked up this little Lazy Susan at the thrift store. I soldered the wire here to the point, and then what I'm going to do is just get out a frosting knife, and I'm going to add epoxy and spin it. Now this process takes about an hour, but I really like the mundane, repetitive processes like this, and so I just put on YouTube and go away at it. And then once it's finished with the first coat, it looks a lot better, as you can see, significantly better. Another nice thing about the second coat this way is you could kind of work it into some of the imperfections in it. And if you work on it within a 24-hour period, then the epoxy is going to sort of soften the hardened epoxy. The fresh applied epoxy is then going to, as it melts the top layer, it's going to start removing more flaws, and it's going to give you this nicer look, but it's also going to be more functional. So here I'm measuring the resonant frequency, and I think I'm gonna do something here. If I can, let's see here. I don't have it. Oh, here we go. Okay. So I just want to go back here a little bit. So one thing you'll see is the positive wire is connected to the base of the cone. So we have just one wire. The other wire on the cone is not connected to anything. And this is how I measure all of my Tesla coil secondaries. Now, if you move over here to the left, the positive side goes to this resistor, and the positive side connects to the positive side of your oscope. This resistor is between 5K and 10K, and I prefer the lower 5 or 6K, but it'll work up to 10K. And then on the other side of this positive is the positive of the signal generator, and then the negative part of the signal generator is connected to the negative part of the oscope probe. So I kind of just wanted to explain that. And now the second part of this is now, so you look at this here, it's 10 kilohertz here below. And then if you look at the oscope here in the lower left-hand corner of the screen, it says 10 kilohertz. So this is really the starting point on your journey to try to find the resonant frequency. Oops, I think I went too far. Let's see here, did I do this right? Just check here. Let's see. Oh, I'm sorry, the slide's out of order. That's okay. So when I'm playing around with it, I'm playing around with it because it only really resonates at 2 point something volts or at 8 point something volts, and that's AC. And so I'm just doing a little bit of experiments because I can't get a big discharge. I cannot find the capacitance that works with this until I figure out to take the capacitance off, and then it starts to function better. And here's me goofing around again. It's funny, is it's coming out pretty grainy. It was a lot clearer when I filmed it. So this is a one of the many tubes that comes in a kit. You can buy it from China. It's the kit where you turned it into the handheld Tesla coil that Nathan has shared. And so it comes with all these vacuum tube, not vacuum tube, but these little element gases, noble gases that are in these tubes. And so they come out with the different colors based on the gas. Now here's 8 volts AC. And we're sort of getting what we want, but not really. You should see again that inner sine wave to go much larger. Now, as I was just trying to figure this cone coil out, I found out that it was doing something strange. So the ground wire is connected to these copper spheres, and just by happenstance, because my lab bench is messy, I just had the copper spheres sort of tossed to the corner, and with some tubes in between them. And this surprised me because this is about 18 inches away from the cone, and it's ground. Ground shouldn't be having this kind of effect. Normally, ground is an equalizing effect, but for ground to be radiating this kind of energy, this is new to me. It'll come up here in a second. So it's new to me that I'm getting the ground to radiate. So this is a whole new source of wireless energy in this experiment, and it's pretty interesting. There's actually quite a bit because these tubes here, they need a little bit of high voltage. They're not going to just light up. So this one, the purple one here is I think argon or helium, and this orange one is neon. I think neon's my favorite out of these evacuated tubes. So I start just sticking things in here, running things around, and I start to experiment how if I touch the copper spheres, then it lights them up as if I'm touching the Tesla coil. and this is ground. This is since the coil, the actual coil is about 1 foot to 18 inches away, and I'm just trying to figure this out. How is it doing this? So pretty interesting. And as you can see here, I'm getting a plasma discharge. It's pretty weak because it's only 8 volts, but evidently there's something going on over here. And I think this might be an avenue as part of some of the one wire energy experiments that Nathan is sharing, because I'm really surprised that I've kind of moved another radiating source that works in conjunction with the coil. It's pretty fascinating. So I think I just play a little bit more around, kind of get a feel. I'm not resonating yet. It's just a low voltage, trying to figure things out. And I had the neon tube work, so I'm just trying different tubes on the copper spheres. And yeah, it's fascinating stuff. Let's see. This surprises me. I touch them, and I just can't believe how it turns super bright when you touch them. So you can just tell there's a energy density there when the spheres are touched. All right, we're going to put in another 8 volts. Again, a sort of kind of decent resonating, but not really. It's not good, or it's not great. It's okay. Now we're going to look at this cone upside down, and I'm using still the copper spheres as part of the ground, and I'm connected to the ground in my home. And this is something that surprised me too, because as I place evacuated gas tubes here, they're only being lit up. If I were to put this, let's say, on the sphere, or if I were to put these on my cylinder, there would be internal arcing. There's no way that you could put these on those other designs. Now you might say, well, the epoxy's thick. No, I have a thick epoxy cylinder, and I've played around with it. You cannot put evacuated tubes like this. So there's something about the design here where if the cone is right side up, it sort of has like some kind of pinch point at the top. But when it's upside down, it sort of has this, I don't know, a softer but larger flow. I don't know. All I know is it's not arcing and sparking, which is good news, and it's very fascinating. Oh, sorry, this is my notes. I'm going to work on designing a ZVS that is modular and has really thick wires. The reason for that is I tend to blow up the traces on the PCBs. I haven't figured out how to make the traces thicker yet. I've talked to JLC PCBWay, hey, can you make the traces thicker? And they said, you have to do it on your end. So I thought I'd go down this route, and I was going to pick the brains of you guys on maybe some ideas of how to just use some really good thick wire and create a ZVS that's easy to remove components if they fail, easy access, and they can take super high currents. So just spitballing there. Now, as I was working on the cone, my ZVS boards stopped working. And so this was my hot rod. This is my big ZVS coil. And I was just so angry because all 3 of my ZVS working boards were toast. So I just began cutting off components and testing them until finally I discovered that there's an open in one of the traces here. So that kind of goes back to my point that we need thicker traces for current. And so I just got in a little frenzy because I was so frustrated. And I don't know if you've ever worked with ZVS circuits. Nathan can tell you, anybody can tell you that it is a lot of finicky getting it just right. Now here's my hot rod version 2, has the blue light, and again a garbage signal, an uninterpretable, bizarre signal from. Now that looks pretty good, so it's better. Now I'm applying the same AC, but I positioned the concave primary under it, under the cone, to be a little bit more evenly spaced, so it doesn't come apart or discharge plasma over at the bottom and then start ruining the coil. And so here I'm just trying to figure out how much energy now I can put out of it. Now I figured it out, and I did share this with you guys last week, but this has no capacitors, okay? This is just 2 cones. And now I'm going to add the series voltage and some series current. I'm running about 15 to 20 volts AC input, and I'm going as high as 15 amps. So we're going to see that we're going to see some better plasma discharges. Let's see here. Okay, is this finished here? Let's see. Yeah, okay. So now you can kind of see the upside down setup in the light, and if you can see back there, the cone is actually touching. It's at the lowest point, so the primary coil is evenly, I guess, distributed. It's not sitting on top of the cylinder primary coil, the piping, the copper pipe. So now again, I'm seeing that it puts out quite a big charge upside down as it does right side up, and I think it might even be more powerful upside down. And so that's a bit surprising to me as well. I was expecting that the point would be a pinch point and push off more or push out more plasma. Now, Jarvis had sent me Tesla's patent on his cone coil, and his cone coil doesn't go to a point. It's pretty much cut off at the top. It's still conical shaped, but it's not to a point. And he said that I should probably cut this coil down and make it closer to Tesla's coil. And so I plan on doing that. I didn't want to do it now because I wanted to get you guys some good footage. I was out of commission for quite a bit of time, so I wanted to rush this out and get you guys some stuff to see. So we're getting it out of the bottom, and it's very strange. At least I didn't expect it. Maybe it's not strange for some of you guys. And here's my trusty infrared. I use it all the time because I don't like swapping out components. So if I see a hot spot, I'll just grab my little house fan, my little desktop fan. I'll just put it on it so it keeps them cool. Or if the circuit acts up, I'll use this, and it's always the component that's the hottest is the one that stopped working. So great thing about this. Also too, you'll see that there's some interesting hot spots there in the middle of the cone. That's fascinating to me too. I mean, why is it in the middle? I mean, it should be maybe at the point, because the point goes right into these copper wire turns. Or why is it at the top where it's discharging? No, it's right here in the middle. So that's interesting. And so now it's still upside down, and I'm going to just keep cranking it and cranking it, just like I do with my other coils. And yeah, I'm seeing quite a lot of discharge, and it looks like my other coils. I think there's some differences, and but it's close. It looks like a mix between AC and DC to me, because as you noticed in my sphere earlier, the lightning bolts, if you call them that, were a lot stringier. These got a lot of fluff to them. In fact, I just want to see that fluff there toward the end. Let's see here. Right. Thanks for being patient. Let's see here. Okay. It's a little blurry. So it's got a whole lot more of this ion cloud around it. than you'll see with my other coils. It's this like a misty cloud, and the video doesn't show it or do it justice. It's a lot more of a haze, a three-dimensional haze. And so that was something that caught my eye, that was different. And so that's why I wanted to slow it down and kind of give you an idea of that, but it's getting a little blurry here. So, all right, we're going to put 15 volts AC in. That's an okay signal, even though it's not what I'm used to. And look at that, we're getting a pretty good discharge. So if anything, it takes less volts for the cone, and that I'm not sure why. Maybe because it's asymmetrical, it drives denser parts of the geometry to have denser energy. I don't know, but for 15 volts, that's a lot of spark for it. And then I did this for Nathan because he always likes to see me send plasma to the ground or have the ground suck in the plasma. And he calls this a pump, a plasma pump. So I thought this was pretty cool. When it gets brighter here and thicker, that's because I'm turning up the current. Well, I'm turning up the voltage, but adding more current. And it does that sort of flame look, that yellow, light violet, purple, white flame. And so it's very fascinating. There's some interesting geometries again right here. Let's see if I can pause it here. Show it here. I always have the best. Here we go. Let's see here. Oh, there we go. So it has these lines. I can't. Right under this button here it can show you sort of slithers. The tendrils are sliced, and maybe there's another one that I can show it. Okay, so the tendrils here are sliced, and you can see them sliced. Not the best. Here's another one you can see. So they have these little cuts in them, and that's what I've noticed that's different. I'm not sure if that's a big deal, but I like to sort of align the plasma differences to the shape of the secondary coils that I use. Now I'm using the comb that comes with these kits. And so with these high voltage kits, China says, hey, comb your hair with this comb full of plasma, and then it'll cause your bald head to grow hair back. And yeah, no FDA studies on that one, but there's a helium or an argon in there, so it looks cool. So here I'm just starting to fiddle around again, and then I'm going to show you where things start getting a little interesting. You'll see a discharge here, a little plasma breakthrough right there. I don't usually get that when I have that set up, so that's interesting. And we're going to see more of the plasma discharges in places that you don't expect. See here, this is a radiating coil too, because you'll see those neon behind there, and that's again a good foot away, and you'll see, so I'm going to drag it up, and it puts out a decent amount of energy. Now, if I were to do this with a cylinder or a sphere, it would not have this much radiant energy, just from experience. And so I think that it's got some sort of more efficient power, wireless power. So I thought I'd just put the light bulbs here and see how many I can light. So the different colors. Now, I was looking at this going, wow, look at these colors. And then all of a sudden I saw this new color, and I'm like, oh, whoa, what is that new color? And as I was looking closer and closer, I noticed something not good. You should see it here in a second. So there it is. It's getting, oh, sorry, I turned it off. So you'll see here where it's touching, it's getting brighter and brighter. And I thought, wow, it's having some sort of extra plasma effect. And then I discovered, no, it was just setting on fire the plastic cup that I'm using for this. So look at that, not good. I have to get R2D2 out, the fume extractor. Oh, these are the specs of the sphere. If you ever guys want the specs, I can send that to you. Change gears here a little bit. So I wanted to wind a new concave coil, and I bought this reel of copper pipe. So I measured it, I cut it out. Whenever you're working with the pipe in the shapes that I use, either the concave or the flat pancake, these are the steps you want to take. Now the cylinder, winding the cylinder is pretty easy compared to this. So I thought I'd share the steps real quick. So one of the things is that inside of the start, it has to be a little bit larger so the coil you put in it has space. If you don't do this, then it'll either ride too high or too low. So as a rule of thumb, put the coil that you want to use as your secondary in the middle of your copper tubing, and then make sure that you have a gap and it fits in just nicely. And then of course, I cut it. Though, see these pinch cuts, I don't like that. So I'm going to be changing that here in a second. And so you can see here, it's not a clean cut. So I picked up this little pipe cutter. This is great because you also want to make clean cuts on your pipe because you may want to solder wires inside and do different things. So I use this little clever instrument. It's probably in one of my miscellaneous videos, but this is a really nice way. It's cheap, get it on Amazon, and it just cleans up your pipe primary coils. Now I'm ready to go. I'm just going to create that concave, that bowl shaped, just like I did last time. I get these cheap connector terminals, and look at that, it's perfect. So I'm going to do the same thing, and here it is done, except for it was too long over here, so I'm going to use my little pipe cutter. But that looks amazing, and sizes and everything, but it doesn't work. It absolutely doesn't work. I tried hours. I could not get this beautiful primary coil all evenly spaced, no kinks. I could not get it to put out anything in this coil. So that bummed me out. So I had to go back to the funky one that I wound. And so I'm going to play around with that one now. And as I position the concave a little bit better so it doesn't spark below, I'm getting more and more plasma. And I'm doing it very slow. I use the analogy of trying to blow up a water balloon with a fire hydrant. That's what it feels like here, where everything is just super balanced. There's a weakness anywhere, this will find it. So we're going to start seeing what happens on how weird this coil gets, because this coil gets a little weirder here pretty soon. So I just wanted to show you that I'm figuring it out. This it had kicked my butt up, down, and sideways, and now I'm getting better. And so I'm doing my customary top camera shots, side camera shots, and looks pretty similar, but it has its own distinct look. There's some stuff I want to do with the tip that'll help later, but I wanted to get this out to you guys. Excuse me. Here I'm gonna add more and more. Now there's no capacitor here, so it's just 2 coils. And I'm gonna be getting probably over 10 amps and about 25 volts. But I'm doing it super gradual. It's funny because if I go quickly, it just shoots off in different spots at the bottom and the top. Now see at the bottom there, see what happened there? Let me see here if I can show you. You can see there the little light storm there at the bottom of the cone. This right here is, and you've seen this in my other presentations, and it's lighting up the entire inside bottom. It's pure plasma coming in contact with thick epoxy, and it's creating this bright light. Now, this signifies the end of me experimenting with this coil. I've had a beautiful sphere. It did this, and it just stopped working. The only thing it would do is it just catch fire. And so this is a sign that I'm not going to be able to keep this cone coil long. So it's unfortunate. But I'm going to just take Nathan's advice and fry it and find out. So here I'm just going for broke. I just turn it upside down and start cranking it. Now this is, let's see here, let's do this. This, and I will, if I can get it here. This, I want to show you. Let's see here. You can see that a whole fractal discharge is happening at the bottom now. So that's crazy. I've not seen that before. Let's see. Okay, so you see it reminds me, this little white part here, it reminds me of lightning storms on the planet Jupiter. I don't know if they've shown you the lightning storms under the thick atmosphere of Jupiter, but it just feels like that to me. And I'm going to play this real time, but I just wanted to point out a couple more things. So you'll notice that now that it's burning up inside and it's on fire somewhere inside because it's smoking, you can see the tendrils have totally changed. And then what's up with these? Why is the ground discharging like this? It's like turning itself into a bifilar when it shouldn't be. And I've not had other coil ever act like this before. Okay, so again, you see a little lightning. If you look at the top and to the right, you'll see that it's just on fire inside. I'll play it full speed. I just want to point out a couple more. Oh, there we go. Point a couple more things out here. So what's going on here, you can just, it's a little smudgy, is it's literally burning the wires. It's just set fire to these wires. Now I'm going to start it from the beginning now, so you can see it a little bit more fluid as it's appearing. So you can just see to the right, all that white's bad, okay? And then see it stop? That's because it cut the wires. The internal plasma fire cut the wires, but then the heat is so great, it reconnects the wires. Then the heat's so great, it reconnects the wires. So what you're seeing here is just this on and off effect as the plasma is just obliterating the enamel off the copper wire, disconnecting the copper wire, reconnecting the copper wire. Now, I've never seen anything like this. It's always, I fry it and find out, and then it's done. You can do nothing else. But this, I just keep pumping in the amps, pumping in the volts, and it just keeps functioning. And so I just was going to go for broke. I was going to go as long as it was going to go. And so I just stayed with it and just watched it. Now this, again, this phenomenon here was crazy at the bottom. What is going on? And there you see on the side there, that's pure, it's happening in billionths of a second, but the temperatures there are equal to the surface of the sun. You can read about that in plasma, but that's what's going on inside here. It's destroying itself and healing itself, and it's pushing out plasma that looks totally different than what it did before. Who knows why that plasma looks that way? And then it's turning the ground into a plasma discharge. You can see that the radiant energy is so powerful from the bottom, which is the point, that it's starting to cause my camera to have that weird effect. It's starting to have the camera go this weird effect right here. This doesn't happen to my camera when I use it on all my other coils. So the point, which is the bottom here, this is the point part, even though you're seeing a fractal plasma discharge on the ground side, which I still have to try to figure that out, but the EMP from it is so strong, it's actually now affecting my phone when I've not had this affect my phone before. And I almost stick my phone into the plasma on my other coils. This is about 5-6 inches away. So that's another interesting observation. Again, I'm just going for broke and frying it and just seeing what it does. I'm adding those vacuum or evacuated element tubes. And I'm just seeing when it's going to finally eat itself alive. And yet it just keeps doing different things. The lightning storm inside is changing colors, and the discharge is getting more stringy, and it's not turning. Oh, it's turning off and on again. And so you saw that it got really kind of normal there. This is another thing that surprised me. There's not a single bit of visual damage. Zero. It's clean. And now if it's at least coming out of the bottom, you could see at least some damage in there, and it's crystal clear in those holes. And I look in those holes and there is zero damage. So that kind of, so there's something about this energy where it's doing its own thing. I don't know what else to say. Oh, wow. I thought I was going to have a shorter presentation. Thanks for hanging in there, guys. Excuse me. So I'm just doing some tests again. You can still see the inside, the cone is still eating itself alive. And I'm just trying different things. Running the coil, you can still see inside, the plasma's chewing on itself. And yet it still has an output. So I just keep doing it, just keep cranking it up. Now it's getting to be more conventional. It's starting to get back to its old self, and that I have no idea how that happens, because it must be some kind of even melting, even heating. And now the alligator clip is putting out plasma that goes to ground. Now I tried to catch, this is kind of funny, I tried to catch a good close-up to the alligator clip over here pushing out plasma, but the cone coil just drove a nice lightning bolt right into my arm. So that's why I kind of go back crazy. But another interesting aspect, and now I'm starting to get more and more plasma out of it. It's self-healing. I don't know how else to say it. It's self-healing. And so I'm still just not afraid. I'm still waiting for it to die. Running more of the radiant energy test, seeing how much it can power up. Bring it up a little closer. Still has the stringy discharge, but it has a lot of radiant energy, which again, normally if you have a discharge, the radiant energy is not that good. It's not this good. Let's see. I'm almost done, guys. I appreciate you hanging in there. This is the neon gas with this customary orange glow. It's my favorite. Oh, what I'm showing here is I can get about 18 inches away. And that's a lot for the coil that I'm working on. For these coils, for that discharge, that's a little bit, that's a lot of bit different. All right, a couple miscellaneous. Sometimes I'll be working with my O-scope probe and I'm not getting the right readings, and I'm pulling my hair out, I'm losing my mind. And so as a sanity check, there's a little metal piece over here in the bottom right corner, usually on O-scopes. And I connect the positive to the first metal piece, and then I connect the alligator clip to the bottom piece. And so what I should get is a perfect square wave at 1 kilohertz. Now, if you don't see this, then your probe needs to be either adjusted or you need to go in the trash. Now, it's not uncommon to destroy a probe. It's because they're sensitive devices, especially what we're doing. So I had another probe on here, and I didn't get this beautiful square wave, so I tied in a bunch of knots, and I don't know what I'm going to do with it, but it's broke. And so this lets you know, you get a little sanity check. There's also a little screw on your probe. So if these square wave tops or bottoms aren't perfectly flat, there's a little set screw, and you can just adjust it. And then when you get a perfect 1 kilohertz square wave, you know that you can have some confidence back into your probe, because probes fail and they'll drive you crazy. At least that's my experience. Let's see here. What am I doing? Oh, I wanted to point out, I forgot to point this out. So the resonant frequency for the cone right side up is different than the resonant frequency of the cone and it's upside down. And it's a difference of 13 kilohertz. So it's not a small difference. It's not a 1 kilohertz or 2, which would be within a range of error. No, it's a 13 kilohertz difference. The pointy side up has a 77.7 kilohertz resonant frequency, and the upside down, it has a resonant frequency of, I want to say 69.4. So now what I'm doing here is I'm showing you exactly how to tune it. I'm incrementing the signal kilohertz at a time, and I'm waiting for this fuzz here, this fuzz bar, to shrink. Okay, so did you see it shrink? Let's pause it here. Okay, so see it shrink, and then it goes up, shrink, goes up, shrink. I'm sorry, goes up, shrink. Okay, I kind of wanted to embed this into your thinking, because the more it shrinks, the closer you're getting to resonance. And so once you shrink and then go back up, don't keep going up. You have to stay there, and you have to sort of dial it in from there. So I wanted to share that because it's not an easy concept. It's not easy to explain. It's an easy concept. And so here I'm bringing it down, up, down, up, and getting it small as I can, tuning it. Okay, it's 77 kilohertz. Now I'm gonna go into the hertz range, and believe it or not, it's 777 or 77.7. I thought that was an interesting resonant frequency, because the ohmage, the ohm value, the resistive value of the cone is 666, 666 ohms. So you have a 777 resonant frequency, and you have 666 resistance. Those are some interesting numbers. And I'm showing you how I ground when it's upside down, and I get the cone tip as close to the ground as I can, close to the bench as I can, so that way when I put the piping coil around it, it's centered, so we're not getting any, oh, you put it too high, you put it too low, that's why you're getting the weird readings. No, this is on the bench like the other side, it's just upside down. Here I think I'm measuring it. Oh yeah, I'm measuring it the other way, so I already explained it. This came in the mail. I'm excited. I was thinking that it was going to throw such high sparks that I needed my welder's hat on and my asbestos suit, and this is what it gave me. Yeah, it's a big dud. I'm hoping though that I can get a strong enough electric field out of it. See, I got 10,000 volts out of the field of the wire, and that's positive. And I get 10,000 volts negative on the other side. So it has a decent electromagnetic, or I'm sorry, an electric field. And as I've shared earlier, one of my side projects, it's becoming my big project, is I'm working on building electrodes with Brent Jarvis. And so I'm trying to just find the right high voltage power supply that I can use to achieve a strong electric field to make the electrodes. Now, I have some materials here. So these are the taser modules, Jarvis calls them. And I've gotten these three to add up to 10,000 volts. I have the previous power supply you saw, that's 10,000 volts. I'm kind of working with that 10,000 volt number right now. I just thought it was a good starting number. These rubber coated bars here, I got it out of a laser printer. Again, of course, a thrift store. And these are going to be part of my high voltage static electricity, high static voltage electricity. So I'm going to have these spinning with wires touching them and creating massively large electrostatic fields. So I'm kind of just walking around my bench here for my electrodes. And here below, this is pure mica powder. And I was surprised to find out that pure mica powder is used in cosmetics. It's safe because it's organic. It's not a chemical, and it allows your makeup to sparkle. But oh boy, mica is one of the top most you can find, and so I'm building a positively charged electret. I want to have positively charged naturally, so that way I can get that extra edge when trying to get as many electrons out, so that the electret is so powerful that if you were to hold it in your hand, all the hairs on your body would stand on end. That's the goal. And so I want to do it with mica powder. Mica powder is number 2 in the strongest natural positive electric field. And then number 2. Number 1 is glass. So I ordered some powdered glass, and that's the number 1 naturally positively charged. Now this thing here, I took it out of something from the thrift store. And what it does is it has a heating element, and it blows air through the heating element. And so I'm going to use that to heat up because the less the moisture, the easier it is to rub a static charge. Now at the thrift store, I found this ultrasonic jewelry cleaner. And so I'm going to be using vibrations from this to really rattle the mica powder or the glass powder, and to basically rub as much surface area as you can, because the more surface area you cover, the larger the charge. And so that's the idea of shaking it with ultrasonic sound. And then also, so I'm going to take that thing apart and make one creation. Here's a jewelry, not a jewelry, but a rock tumbler. And so I'm going to be putting in the glass, possibly glass and mica both. I haven't decided. And this thing's going to tumble it. And what I'm going to do is I'm going to, let's see here if I can do this. Here we go. Getting better at this. So what I'm going to do with this tumbler is I'm going to have a high voltage positive probe that's going to come through here. And of course, since this is spinning, it's going to need to have bearings. I've taken that in as part of my build. Excuse me. But I'm going to highly electrify the tumbling materials in here while I'm hitting it hard with ultrasound. So it's heat, it's ultrasound, it's tumbling, and then it's a super, super high electric charge, a positive electric charge. And that's with the goal of making a powerful electorate. And I'm under the guidance and help of Jarvis, but he kind of lets me do what I want. So I'll put a bunch of stuff together for my own brainstorming ideas, and then Jarvis will give me course corrections or tell me that won't work. And so I appreciate that. He's just been a great mentor on this project, and I'm pretty excited because there's a lot you can do once we get these working. So there you go. That's some of the materials for building electorates. Oh, this is pretty cool. So about $3 at the thrift store. I got these really amazing egg-shaped glasses that have a flat bottom. And as you know, I've been working on a cloud chamber, and I've had a few setbacks. Jarvis has given me the good idea of using cascading Peltier modules so I can get it colder. So I really think because the visibility here is so great. I mean, if this is the cloud chamber, you get a three-dimensional look of the evaporated alcohol inside, and then the fields and oh my goodness, the particles that are going to be affecting to show us what is invisible to us. Forgive me, I am having a hard time speak. Now, still on the vacuum, the cloud chamber, I found this ice cream machine, and you can't guess where I found it, thrift store. And what's cool about this one is this bowl here is filled with a kind of gel. And what you're supposed to do is put it in your freezer and then pull it out, and it stays frozen because it's insulated and it's some kind of cold holding materials, and it becomes a cold surface. And so living up here in the frozen north, yesterday was minus 9 degrees. I can just put this outside. I don't need any fancy cooling. And then I can put the egg on top of that cold surface, and I might have a cloud chamber. So this looks interesting, but this is the direction these are just the things I'm trying. So here I'm envisioning that it might work out this way, and also it might work out this way. Either way, this thing has to be immensely cold, and then I'll need a little felt somewhere to soak the alcohol, so that way it evaporates, and then the particles will do their work. Now, Joe made a good point and shared it with Jarvis, who shared it with me, is to be very careful, because if I'm evaporating pure alcohol, it can definitely be an explosion hazard if there were arcing and sparking. So I appreciate that safety tip, and I will take that into mind, because in order for this to work, you need 99.9% alcohol. And of course, if it's in a gaseous form, it's going to be very flammable. And if it's contained and it's very flammable, it could be explosive. So I appreciate that. I appreciate that, Joe and Jarvie. Thank you. Let's see here. Oh, okay. So I'm going over time. Sorry, guys. So I am finally going to start building a bifilar, but I just wasn't happy with the thick wire that people use to build bifilers. I want to, like my Tesla coils, I want to be able to have 1,000 turn bifilar. And since a lot of patents I've been looking at require bifilers, I'm going to use this specialty wire. It's rectangle wire. The cool thing about rectangle wire is it's only 0.1 millimeter thick. So if I run it in a circle like this and wind it, I can do, this is about 500 turns of wire just right here fitting in my hand. So it's very thin, so you can get a ton of turns of wire. But if you're worried about current, it's 1 millimeter wide. So you kind of get the best of both worlds. You get it thin so you can get a whole bunch of turns for a whole bunch of power, radiant energy, and yet it's got this wide space that's going to allow you to hold current, which is also going to be needed. So that's on now. That's made it on my workbench. I thought I'd share. And the last thing on my workbench is, because of the frying of my beautiful ZVS boards, I had to rebuild them. This is one of the other ones I rebuilt. I'm sorry, just built from scratch. If you notice here, these black wires, they're connected over here to the drain of these MOSFETs. And then if you'll notice, these red wires are connected to these 470 ohm resistors. The reason why I'm doing this is because when I add 12 volts to this, I can connect any coil capacitor combination and it'll give me the exact resonant frequency. And so this won't be for pushing out plasma. This will be for being a automated resonant frequency finder. Now, I just put this together as a concept so you guys could see it. But this is on my workbench because I'd love to just, Ian has that great capacitor that's adjustable, and that's going to automate some of my experiment tasks. If I had something I can just plug in and say, all right, this capacitor and coil has this resonant frequency, awesome, we're golden, or other combinations. You need 3 variables for resonant frequency to get a Tesla coil working. You need the primary capacitance, the primary inductance, and the secondary resonant frequency. Now, if you guys remember in high school, if you have A plus B equals C, if you only have B and C, you can find for A. If you only have A and C, you can find for B. It's the same thing here. This board will let you find out capacitance and inductance. I'll have the resonant frequency calculated. Or if I have other variables, this board is going to make it very simple to find the resonant frequency. And so that concludes my presentation, guys. I always enjoy our talks. And so, Nathan, that's the end.
Right on, brother. Hey, how far is that rod going down that that cone coil?
Oh, those holes at the bottom of the cone coil?
No. At the very top of the cone coil, there's a rod. You put
Oh,
the
yes,
bolt
at the
up.
pointy end. The pointy end.
How far does it go down?
An inch, probably.
Okay. You're putting a rod down the center of your Tesla coil. You realize that, right?
I had no idea. That literally slipped my mind.
You're
Oh my
flipping the
goodness.
field. You're in cold energy now, not hot energy. So now that plasma shouldn't hurt you at all. As a matter of fact, you can put your hand right in it.
And I was zapped a few times, and I was going to say that it didn't have its normal bite. So you're just confirming it. Oh my goodness.
The swirls give it away.
Ah, that's good to
You're
know.
always getting stringy voltage out of your other one, Sean, out of the hot energy, and you're getting swirls out of your cold energy. In your round Death Star coil, you're pulling the negative. You flip the field on the inside by the geometry that you use.
Wow, I didn't think about it that way.
That's
No,
why.
that's-
So now think about your ground connection. If the ground is cold energy, and you're using cold energy, the two match, right? So it pulls it in.
Ah, yeah, I've never thought about it that way. In fact, I want to now drill a longer hole so I can put a full rod in there because I did. Yeah. Oh my goodness.
So
Thank you
by
for
the
that.
way, when you put the cone upside down, now you're in bipolar mode because it's only picking up the very first 3 coils that you put in there. The rest are not resonating the bottom cone shape at the bottom. So
Okay.
you're getting a bipolar output. So you get top and bottom going off.
Right.
And you see what I'm getting at here? And your bipolar is both directions. So if you put a rod down the center of one, you should get cold on one side and hot on the other. Unless something's broken, obviously, but
So, but yeah, I have a question for you after you're done. Sorry.
no, go ahead.
So, you know that when you ground one side of the secondary coil, that it's not a bifilar, that it is a standard coil because it's grounded on one side, right?
Unless you're in negative energy.
Okay. Mine was grounded and it went bifilar. That's what shocked me, because you saw the plasma at both ends, but that's grounded. And that shouldn't do that, right, Nathan?
Well,
It shouldn't.
there's an interesting fact about it. Remember I showed you earlier the light bulb, and when you grounded it using cold energy, what happened?
The
The other side of the light bulb lit up and made the whole thing brighter.
Right. Right.
You're pulling energy from the ground. It's pulling up to meet it. So you think it's a grounding things out. It's not. You're pulling the energy from it.
But you ground your Tesla coil, your ZVS, and
but it's a broken circuit because the rod down the center is attached to absolutely nothing. So it's open to circuit up. It's no longer a closed circuit. If I connect it straight to my number 2 coil, then it's a closed circuit. But I didn't. I opened it by putting the rod down the center.
But your number 2 coil is connected to ground.
Yeah, absolutely.
And then you're not getting discharge on both ends while it's grounded.
No, because it's just a Tesla coil. But if I would connect the rod to ground, it would.
Sure. So why is my coil grounded like the other coils, but it has also a discharge? And you even saw the discharge from the alligator clips. That alligator clips are going to ground.
Your field flipping. You're flipping your field inside out, and you're not realizing that you're doing it, and it's causing that ground to pull the energy out. That's why it's so impressive.
Wow.
People say there's no energy in the ground, but then you could make an earth battery, right?
Right.
Well, what energy is in that ground? Well, it's that negative energy that's in that ground, or the cold energy. You can call it what you want. Negative radiant energy. That's what's in the ground.
Right. It's an abundance of electrons. It's negative energy.
Yeah, I mean, if you understand energy this way, you'd be okay. If you don't, it's going to make you crazy. It just make you crazy because it'll bring up anomalies you won't understand.
Yeah, and I was having fun, but it just wasn't acting the same. So when I didn't make this point in the discussion or in my presentation, but if it's right side up, pointy side up, you cannot put a capacitor on it. It will do nothing. If it's upside down, you need capacitors. That's another bizarre thing. Otherwise, it won't work. It needs capacitors when it's upside down.
Well, your primary cold geometry is different in each configuration.
It is.
You can't discount that.
Right, you're right. It's asymmetric.
Secondary is completely, in field flip. It's you're changing configurations, and you're not like eggs, apples to apples. You know what I mean? I was gonna say eggs to eggs. That stupid egg flip.
Yeah.
Oh, hold on real quick. I'm gonna pull this out. I want everybody to see the background, guys. That whole egg thing was a total disaster. So hold on, let's watch real quick. I just wanted to show everybody that.
That's awesome. That's so hilarious. You're getting a laugh aloud.
Yeah, it was a total joke. Anyway.
Well, appreciate that explanation. I think that helps. Do you want to run to some questions in the chat?
Absolutely. Pull up as many as you want, Sean.
Awesome. Thank you. So Ian Jackson, let's see. Nathan, have you tried plastic siphon tube with salt water inside with bolts at either end for the cold energy yet?
No, I haven't, but that sounds really interesting.
It does.
So just a tube with salt water in it, right? And like pull the air out, so it's just salt water. Is that what we were talking about?
That's
With an electrode at both sides.
Let's see, siphon tube, bolts on each side. With bolts on each other side, maybe the bolts are the electrodes. I don't know.
We could try that because we may get if it's cold enough outside, we may get some blue plasma out of it.
Yeah, yeah.
That sounds pretty cool. I'll buy one of those little pumps at the auto parts store next time I'm down there.
Yeah. Thank you for that, Ian. So I'm going to be working my way up instead of down. So Magneto Frico. Let's see, you can also map fields with an open-ended 90-volt neon connected to a long wire, which is connected to the center rod. Can see the null zone much better. A wire with a neon bulb to measure the fields. That I know. Yeah, I don't know. Interesting. Okay. Let's see here. Mr. Lanius, they're having a conversation. Sean, did you try aluminum plate below the cone? No, I haven't. I know that I think you shared that with me already. I just haven't gotten around to it. It's a tricky thing though, putting a metal plate under a Tesla coil because the metal is really close. So yeah.
Well, hold on. You have that thick amount of epoxy, right?
I do.
You're probably looking for a capacitor out of it.
Oh yeah.
So
I think that's what he's saying. Yeah.
Yeah, put some aluminum tape down there, cut it to the shape, and see if you can get a capacitor out of it.
That's a good idea. Very cool. Let's see here. Looking at the questions here. Good conversation.
Hold on real quick. I'll answer this question right here. Any update on the gravity flyer? Well, I have a test that I'm going to begin in a couple days, and I'm going to flip fields on it, and I am literally going to change the website on my TV and show you exactly how it works. So, and show you the field aspect of that thing. No lift yet, just it's a field generator, and I'll generate a field in order to change my computer, and it'll start bleeping like crazy, and then all of a sudden we'll start pulling up different Google pages.
And that's progress. I mean, you're digging deeper into the interworkings of how you're going to have the desired effect.
Well, if you think of the nuclear station that they were turning on and off the switches, that's exactly what they're doing. There's no difference in it. I know the field that they're using it and exactly how they're using it. So that's not really a problem there. You know what I mean? The problem is we're having trouble field flipping this thing, and I've been trying, and I just can't get it to flip right. It's always out of sorts, and it's just not right. So, and I'm not sure why, because I could do it with coils, I could do it with a soda can. Maybe that plate wasn't supposed to be, metal on the inside for the center, even though I know that it is because the original had it. It just, something's wrong.
Yeah. It's that effect that you explained earlier, how you're getting that multiplication, that multiplied effect. I mean, it seems like you're just on the right path. It's just all about getting them aligned, right? And they're not aligned. Is that what you're saying?
Yeah. It's just, I don't know how to describe it. It's like it wants to give you the world, but it's holding back.
Yeah.
And by the way, I've turned down the power a ton on this thing, because when you get the right frequency, like I showed you in those multiple coils, you don't need it. It's going to provide its own. So it's a different concept. It's the opposite of what you would think.
Yeah. Yeah, you've shared that where it's not so much power as it is finesse, and right.
Well, as soon as you get too much power in these things, you overpower it and ruin the effect. And
Exactly.
every single thing's got to be accounted for, every effect. And you start overpowering things and you have a real problem on your hands. It's just things stop working. They stop working in conjunction with each other.
Yeah,
It won't scale right. Yeah.
it's like an orchestra, and you got to get them to play the right tune.
Yeah.
So skimming through here, Mr. Lanius is saying that's why he wanted me to chop off the top, is he thinks that there's something disrupting the power or the full effect, and then he sent me a picture of Tesla's coil, and I built this Tesla coil cone eyeballing the old black and white photo of Tesla's cone coil, and then Mr. Lanius pointed out to me it's chopped off at the tip. So I feel like I have to do that, and I'm interested to see what will happen. And yeah, people are suggesting throwing a piece of quartz crystal. And so another asks, the primary is acting as ground. I mean, the primary is not connected to the ground. It can't be grounded. So it's the ground acting like the top of the other end of the discharge point. The ground is discharging when it's connected, and it was even making my alligator clips blue. So that doesn't mean that the primary coil one is grounded, not at all.
So, Sean, did you say blue and not purple?
Yeah, more blue on the alligator clips. It's a blue.
That's the negative energy color that I got when I was outside in the cold from the negative energy of my Tesla coil.
Wow, that makes sense.
It was all blue, it wasn't purple.
Yeah, right. I'm gonna have to go back and replay that, but you're right. It struck me because it was pure blue. It didn't even have those little tendrils, those little streamers, I think they call them. So, and I just kept getting surprised. Why is that electrified? Why is that given plasma discharge? You're not supposed to do that. You're not supposed to do that. So it was fun. Still going through the chat here. So John Bigham says regarding the inside the coil being burning up, the coils kept burning up till he figured out it was the air heating up the air. Sorry, they're on a different conversation. Let's see. They always have interesting topics in the chat.
Yeah.
Yeah, good stuff.
So, by the way, the three frequencies all come together in the gravity flyer. All of them line up right on the oscilloscope without a problem.
Oh, do you have a picture of that?
I do. You go ahead and talk, and I'll find it for you.
Sure. Okay. Let's see. Creative Awareness asks what temperature of the coil. What's the temperature of the coil now? I should have taken more measurements of it. It just surprised me that it was heated in different places. When you work with the cylinder, the standard type Tesla coil, or even the sphere, there's just evenness, there's symmetry. That I find none of that in this cone coil. So it just heats where it wants to heat. Yeah, Stefan says maybe the thin wires have welded themselves together. That's what I'm referring to as self-healing. So you're dead on right. but I've never experienced it. Normally, when you put a huge heat on a bunch of wires, they usually, after that, they're charred and they're covered in they oxidize, that they're not going to maintain continuity. Now, granted, it only takes one hair thin wire to maintain connectivity. So maybe that just that one wire stays together while the other ones burn. I mean, it's hard to tell.
Hey, Sean,
Yes.
you may be welding it to the wire right next to it.
Yeah, and I think that's what Stefan's saying. Yeah, but I just never seen or heard of that. So
I've seen it.
You've seen it on
They
number
melt together. Yeah, they melt together.
Wow, that's awesome, because I don't have to throw this coil in the box of shame.
No, not at all.
Right here. Let's see. It's glowing in the middle of the secondary. Yeah, yes, it was. So partial burning of the epoxy also colored the discharge yellow. Yeah, no, it's correct. The white and the yellow were the epoxy being, what's the word? Vaporized. That's what plasma does, is it vaporizes the surface because of the intense heats. Yeah, it doesn't make sounds like an electrical flame, probably. Yeah, it's near silent. Yeah, you're right on that, dead fish. Let's see here. For the flame to burn upside down in the Earth's atmosphere, it seems it would need to be positively charged. It's interesting. Going through the questions. Good comments.
So, okay, Sean, I think I found it.
Awesome.
So there's a better picture of it, but this.
Oh, nice.
You could see there's 3 rings there. There's not just 2. The top one, it's right below it, just a little bit.
I totally see it.
So you see they directly line up with each other.
And that does seem like it's the right path, because you are finessing the energies into a state of harmony, if you could use that word, because it's not a sledgehammer. It's more of a, I don't even know what to say, a very finesse kind of instrument. And I think that's why I think you've made more strides, because you're not going blunt force or a bull in a china shop. You're more, and you probably did that from the beginning. Run the motors the fastest, just throw everything at it, and the more you throw at it, the better it's going to do. And now you're taking a step back.
Think about it. Normal science tells you higher frequency and it tells you more voltage, right?
Right.
But cold energy tells you lower voltage, correct frequency, and it'll start doing wild things. So when I have plasma break out on secondary coils that are attached to nothing, now you can start to see why I'm getting more energy.
It's amazing. Yeah. Yeah. So Ian, our Irish Ian, the helicopter pilot, he's printed a number of my cones, and so he's going to have some interesting stuff. He just put the epoxy in, and so that's going to be interesting. So Creative Studio says, Lord of Plasma, please don't vaporize me. Well, I'll think about it. Okay. Let's see here. So yeah, people are trying to figure out too. Making comments about the different positions of the coil. Yeah, John Bingham says there's a lot of minerals, naturally occurring minerals that are put in cosmetics. Um, yeah, so crushed glass and powdered mica. I'm going to get it out into a grounded surface, and then I'm going to do some, use my electrostatic meter to measure their charge. That'll be nice. Then when I put them in the tumbler, ultrasonic heated tumbler, and then compare and see if the charge goes up.
So I was going to say, if you take some aluminum tape and run it on the outside,
Mm-hmm.
on the flat part of the round thing, it actually puts energy into the whole thing because it's static. You're
Right.
pulling high volts, low amps. So as long as you can make electrical conductivity with it, you're good. So if you just use PVC that was rounded and spun it,
Right.
as long as there's aluminum tape on there for each of the anode and cathode to hit, you'll pull it just fine.
You're 100% right, and that's why one of them is going to have a diode, so it pulls electrons to the earth, but the electrons can't come back. So it's going to have an aluminum with the wire. It doesn't even have to touch, but it has to be close to the aluminum to scrape off the charge. And you're right, you need two of them. So I'm going to be doing that, as well as I'm going to have an electrode going down the center of that spinning barrel, and it's going to be positively charged. So I'm going to be doing both. And so it's going to be a kind of a weird Van de Graaff generator with pumped in with high voltage from the taser modules.
Okay. I just want to answer a question real quick, Sean.
Yeah.
If I'm not mistaken how this is supposed to read, how's one get on the Builder's Workshop? Just email me and I'll set you up for Wednesday of next week. And you can come on and share. This guy right here sent me a bunch of PDFs with all kinds of information about Tesla. Anytime you want to come on, man, you're welcome to. And it'll be a fun conversation. Just email me and then we'll set it up.
So you have your email in the description, or?
No, just he has my email. We've been talking back and forth a little bit. So all he has to do is email that he wants to come on. I'd be absolutely happy to have him on.
Awesome. I had a guy reach out to me, Stefan, and he had some cool stuff he sent me. Can he take that avenue too and contact you?
Absolutely.
And share his stuff with you. Okay, so Stefan, he's in the chat. So
right here,
Steph Fang, as Stefan, but it has a G with no last name. I just say Stefan. So different Stefan.
Yeah, send it to me. Let me know.
See if he's still on.
Yeah, you know what? Everybody who has their side of the information, please share it. That's kind of what this whole thing's about when I do the Fringe Think Tank and this. If you got it, come on, show it, and man, you're good. A lot of people just have different projects that they're working on. Some people are working on peg cells, some people are working on Tesla coils. You know what I mean? Yeah. It's always good to get a different side of it.
And I just want to share with you guys too that Nathan, I just sent a bunch of stuff to Nathan and he said, come on board. And he's been so supportive. He lets you do your thing. He doesn't try to micromanage you. He has a few rules. He'll tell you, no medical, no politics and religion. But other than that, he'll let you share your stuff. So I'm hope you're seeing that, Stefan, and send his stuff, share your stuff with oh my goodness, with Old Man Builds.
It's all about the science, man.
Yeah. So
we got to get Brandon over here to come on. He got wild experiments, Sean. You see him every once in a while. That plasma TV he works with, man. He's abused that thing. I can't wait till he comes on because I got to see it all.
I do too. I love Brandon's work. It's he's Coat Creative Studios.
Yes.
Yeah. So he calls me Lord of Plasma, and I'm gonna call him Master Coat. So Lord Plasma and Master Coat.
We're
His
gonna bring on Joe with him. We're gonna force him on. Yeah.
Yeah, there you go.
He was making his wood, like a wood cutting board,
Uh-huh.
and it was teeter-tottering because he's putting energy into it, right?
Wow.
So he's getting it to like suck down to the actual sink and then pop up a little bit and then rock back and forth like that.
And it's wood.
Yeah, it's just energy, man. It all works the same way. You just have to be able to identify it.
Yeah. Are you gonna share some of the stuff you shared with me, or?
Yeah, I wanted to share. I was letting you go through some questions.
Oh, awesome.
Let's do it real quick because I know you have a time limit, so I want to make sure I get your insight on it.
Sure. A couple more questions and then we'll go.
Yeah, go for it.
Awesome. Let's see. Getting through here. People are interested in the resonant frequency finder. Yeah, I can't wait to finish that. If I get it working, I'll send you guys all aboard. Let's see here.
I got a redneck method for it.
Yeah.
Take a blown ZVS, right? That has one good MOSFET on it. Okay?
Just pick up the power, right?
Yeah, just put it to 10 volts. Okay. And then take your wire, the little clip, and you run it along your primary. And on your oscilloscope, it'll go up and down. Then you hit the right spot, it'll jump, right?
Yeah.
Then take your marker and mark that little spot. That's your resonance frequency, exactly where it is. That is the redneck method of finding resonance frequency.
That's awesome. Yeah, I've gotten away from the clip. Remember, we lived on the clip. You still do the clip.
Oh, I do the clip because I changed my coil so much.
Ah, I get it.
Like, I got one behind me. That's like right there.
Mm.
I literally cut the top 1.5 inches off of winding because it was not at the right frequency. So you'll see me over there. I'm pulling this wire out, right? At this beautiful coil that I built. I'm pulling the wire out because I want the exact frequency.
Right.
So, yeah, it was a kind of a thing. I wanted to cry. All that hard work, all that spinning of that stuff by hand.
And then you gotta take some of it off. Oh.
Yeah, but the reward was awesome.
Oh my goodness, I can't wait. I love it. A lot of talk about crushed quartz. I looked for it. I couldn't find crushed quartz on the internet. I mean, maybe someone can send me a link because I'd love to try crushed quartz as an electret material. So I don't even know if it's a thing. We have such an active chat.
Yeah.
Just a lot of good interaction here. Okay, so Eighth Sinner says you can't say it's self-healing if there is no damage showing. Before it's showing normal, that would be a retrocausal, which is impossible. You're missing something, but it's something else. Well, I think that the damage can be so deep in there that I'm not seeing it, or it's not being damaged, and it's weird. And I just think that this asymmetrical coil that Tesla says it gave him the largest energy output, I think there's something to it.
Sean, do you have a way to put your camera in there and zoom into the actual holes in that coil?
No, I don't. I just have my phone.
I would ask you to look for a plasmoid. Look for EVOs.
Look for
Gerald's
what?
coil pulled off EVOs, and you're kind of multiple windings, one over top the next. You know what I'm saying?
No, I'm sorry.
So look in there and see if there's a hole in the middle of nowhere by a winding.
In my in the cone.
In the epoxy.
Okay.
If you're doing it, you may be pulling off EVOs in there and you don't even know it.
Ah, okay.
So I would check and make sure and see if you did.
Will do. Will do. So it's not self-healing in the sense that like capacitors. This is more self-healing with what I think what you said, Nathan, is just they're being melted and together, then melted apart, melted together, melted apart. I just never had that much good luck. Usually they're destroyed.
Yeah, but if you pulled off an Evo, then it would be a plasmoid in the middle of nowhere. And
So
it may be making all the light in the world.
I can't wait to look. Awesome. All right. Let's see.
So I want to show this, Sean. We're getting late. So
yeah.
Got some updates and stuff. So
Sure. All right.
Yeah, give me just 10 minutes, Ben, and it's all yours.
Oh, you're good. My camera, I'm trying to get it to focus so it blurs out the background, but it's not working, so we'll just run with it. But yeah, go ahead.
Okay, I wanted to show this right here. So what I'm working on, guys, is flipping fields. And real quick before I start this, I'm going to ground this thing out because I wanted to show you guys the energy pulled back to the ground. Then we're going to go onto it, and I'm going to use that soda can and flip the field on you. I'm going to go from cold energy to hot energy. One has to do with grounding. The other one has to do with Don Smith or Edwin Gray. It depends on how you look at it. Let's start off by looking at what we have. We're at 11 volts, nothing big. We can see our light bulb right here. Now, let me get around to this side of it. If you notice, that side's really bright. This side's really dull. Not a lot going on there. Now, here's what I'm going to do. This is just connected to ground. Look at that.
So crazy.
This energy works by pulling the ground through it. Although that's interesting, we can get a more interesting look at something. Real quick, I just want to show you this. There is plasma inside there. It's real nice and purple. I know it doesn't show real well on camera, but there is.
Wow, that's awesome, Nathan.
Look at the
that's so
grounding
cool.
effect of this. You see it immediately got less bright. Put the ground to the side for now. Now we're going to go over to this can that I have here on the table. Let me get around. Okay. We have this can here, and it's basically just has 1/4 inch hollow tubing winding counterwound. Top and bottom are different winding directions.
So crazy. And he takes a sip.
You connect the bottom here to that winding. Probably blow up on me if it had soda in it. And the top right there. That's it. We're just going to turn it on. That's not bad. We got light up. Okay. Let's go back around and we're going to pull our ground through to it. That's pretty good. All right. There's a difference in the energy though. So let me just take off the ground. We're going to go back around this way. Sorry, I'm going in circles, guys. Just have to work around the table. Now, what I'm going to do is show you that when I put it in here, I am now have changed the field. Let me turn up the power just a bit.
He's just giving a little kiss.
Right.
Oh, look at that.
I'm now in hot energy right now.
That's crazy.
I have flipped the field.
It's arcing too.
Now that I know that,
So cool.
you see, I went from wire down the center and cold energy to putting it in that can right there and changing the energy. Why? Because I put tape around that can as well. So I separated it. So now it's one field going into the next, into the can. So it doesn't see it as winding or anything. It just sees it as a mass of metal. Now it comes back out and goes to the light. And we got pretty good light up. Let me go connect in the negative real quick. I'll just set this right here. We're going to just turn up the energy a little bit after that. Look at that.
Wow, that's crazy.
That negative right there. So real quick, we were talking yesterday about Gray, Edwin Gray. And we were talking about his tube. And then we also talking Don Smith. I hope you guys understand right now what we're doing. I just showed you exactly how to build it in that experiment in a very, very cheap way. It's a soda can. It literally has electrical tape around it, you know, and the worst windings ever. And I've amplified that energy way more.
Yeah. It's incredible. I don't know. I shouldn't be Lord of Plasma. You should be. maybe. Oh boy, Old Man Plasma.
Yeah.
It's amazing. It's so good use of ingenuity and mixed with intuition, and it's just incredible. You can just go into anybody's garage, pull out lamps and wires, and all of a sudden on the desk is a soda can lighting up the lights. It's so incredible, Nathan. Getting lots of love.
So hold on. I didn't even get to the good part because it would get even better if I put it in resonance. So this is so far out of resonance, it's unreal. That none of it matches. None of it at all. It's like I said, spare parts. So, hey, Sean, by the way, this is my first throw into the build it out of junk stuff. We were talking about last time. There's my entry.
There's your, oh man. Oh, okay. I got to outdo it. I don't know how.
Give me 1 second and I will pull up the other one I wanted to show you.
Oh, all the bipolars.
Yeah, I want to show you all the coils. So,
oh, that's awesome. This is my favorite.
It's like pulling energy out of the air, man.
I'm going to make a rule and make my next project all out of junk. This is my favorite.
Check this out. I got this thing going. Look, I have my original Tesla coil running. I now have plasma discharge here, down there, over on this one. Oh man, that means
not powered.
Mass dose of energy there. Look at that.
It's,
oh my God, that's bright. Oh wow.
It's crazy. And this is oh, I'll let it finish.
Baby.
I have some.
That's the way it's done. Okay. Sorry, go ahead, Sean.
So how the capacitor that has power, it's using the air, the atmosphere, as a capacitor. Okay, so that's why you're getting the big discharges, because one of the plates, air, is discharging to air. Now, when you look at the other coils that aren't powered, then air is turning into a coil, the primary coil, of a bipolar Tesla coil. So air is a capacitor on the powered Tesla coil. Air is a primary coil to the coils that have no power to them. That's incredible. This is the one that I have to take apart, because if you build enough of these, you automatically know how crazy this is. Even if you haven't, you watch these videos, this is next level. This is next level. I mean, and the cream, the cherry on top is you're powering these 40-watt giant fluorescent bulbs while your bipolar powerless Tesla coils are still discharging. Yeah, I don't get it. It's what? Can I get the input on the powered coil?
So, okay. Let me just jump back over here. So what's going on is I tried to build all my coils exactly the same, but the primary coil that runs everything came in at 253 kilohertz. The other ones came in at 361. And this is a very important lesson for anybody out there. When you resonate your Tesla coil in pure, perfect resonance that it's supposed to be at, okay, it will lower the frequency by 100 kilohertz. And I had to learn this lesson the hard way.
That makes sense, because the other coils turn into capacitors.
Now, I had to build another coil. And what I decided was, well, I'm going to do the math on it and figure out where it needs to be. And I built it at a 28 gauge wire instead of 32 because it's easier on my eyes because I'm old. And I built it a bit long. So what I had to do was unwind it this far in order to hit perfect frequency, but it gave me the ability to do it because I could pull it off one or two winds at a time.
Yeah.
Because what I did to find out what it was is I took Ian's capacitor bank and ran this thing out of resonance. So I forced it to resonate in the 360 range and heated everything up. But as soon as I got the light bulb to light up at a distance on the secondary coils with nothing attached, okay, I knew where it was. Now that I know where it was, now I can match it. So when I built my another primary, I just pulled the winds off till I got to 361, perfect resonance. Now, it makes you ask the question when you do this, because I had to ask myself, what is causing a plasma discharge in my Tesla coil? Because is it the resonance itself causing the plasma discharge? Is it the magnetic frequency I get from the pulsing magnetic field that I'm putting into it?
Yeah, that'd be my guess.
Your secondaries just had zero hooked up to them. They're just, you saw both sides lighting up.
Yeah.
Which is it? So I'm sure like Don Smith figured this out. I'm sure Edwin Gray figured this out. When you have it in perfect resonance, you get extra energy coming out of it because your frequencies match. As long as your primary matches the frequencies of any coil you put in, then you get it. So it's insanity how that works, but I just showed you how they got over unity right then and there. As soon as I put them in frequency, you'll see why all of their coils match.
So I understand. I've tried it, and everybody has worked with resonant frequency. Ben has. When you get close enough, you get all kinds of benefits. But that last little 1%, that is what you're doing. I never got that last 1%. Now I'm drooling over using Ian's capacitor bank because I think I will be able to get into that 1%. But to be in that tightness of resonant frequencies, that's why they're all turning into discharging bipolar coils, because and resonant frequency is not this linear, it's more exponential. So it's more if you get 10% goes to 5%, it's like 5 times more. I'm not explaining this very well. It's that last 1% has more energy than all of the 99 other percent. That's a better way to say it. And you tuned it into that one within 1% tolerance.
Now, here's the thing. When you connect a load to it, okay, we got this comment plus the load. You have to remember, you have to be able to cut off the energy and stop it. You have to, how do I say it? Put it in the cap bank, and you have to make the cap bank equal, okay, to the resonance frequency. So as soon as you start adding things to these coils, they change the frequency on you, right?
Right.
So your primary has to match everything that's attached to that secondary coil.
Yes.
And then the primary must resonate at that frequency. So
right.
When you do that, you'll get all the benefits, but you also get to load. But load has to be a capacitor. And then that way you can restructure the energy right after it. Okay? That's exactly what you have to do. So you're going to go into a capacitor, and then you're going to go into a full bridge rectifier right afterwards. Okay?
Right. I have a plan for that, a sketch, a schematic. If you want it, I can send it to you, where it takes the high voltage and steps it down to DC. If you want it, I can send it to you.
Oh, send it to me.
Yeah.
Now, here was the cool thing. Okay, the first experiment I showed you. This will be the last part, and I just want to tell you this. I am in either high voltage AC or high voltage DC, and it acts like a DC flyback or an AC flyback when it converts. So,
okay,
I'm thinking it's DC flyback, and here's the reason why. My gravity flyer will interact with it when you change the fields, right? So, give me 1 second. Let me see if I can pull up that video real quick. Because it's very important that you know that it does that. If you don't know that it does that, you'll never understand it.
I know. Yeah.
So
I have to dig into that. I think that's my favorite part, is that dialing that close of resonance. And when you're that tight, like you said, you have to take off a few turns of wire, and if you were to move them, let's say 6 more inches, you would have certain things to figure out. It's like you have to place them in proximity, based on, even on a hot day would have some effect than a cold day. I know my coils that are 10,000 turns of wire, when I get up in the morning, it's like 65 degrees. I haven't turned on the heat yet. Then when it gets up to about 70, 72 degrees, my inductances, my capacitance, my resistors are all different. But because you have it so precise, that's amazing. Now, how did you know how far to put them? And were you just doing this intuitively?
I do everything intuitively.
Oh, you got some talent there, brother.
Look, when I put it in there and I have the light and I know I can get it at 5 feet, which I did. I know I'm in the right frequency. Then I move them closer, okay? And I know this about tuning forks. 2 tuning forks, the box pushes the things through sound to each other, right?
Right.
So if you have them both at the same frequency, you have to be able to match the sound. Well, you don't realize it, and I'm half deaf, so I never realized it, but the Tesla coils are ringing.
Right. Oh, yeah.
So when you put them close to each other, they ring together. So put them further apart, they're picking up the ring, but at a distance, so it takes longer to travel, so it's less energy at a distance.
Yeah.
You see, we didn't direct the energy in this. They were ringing up because
Yeah.
I don't know if you guys understand this concept. If I took the ring and put it in the proper perspective, it rings like this up your Tesla coil and then out.
Right.
Well, that's important because that means that every edge, it builds out a layer in a field. It's scalar, and it building out each layer at each temperature level. Now I know specifically the distance I can put something at because it's a given.
Yeah.
It's automatically known that it's scalar, its temperature and frequency at that spot because of my ring itself. So it was fairly easy to pick it up. Now, by all means, you could think of it as something else, but if I can tune this based on knowing that, I must know something more than what you're thinking I do.
I mean, sound is acts like electricity. I mean, sound is vibration of atoms, and electricity is vibration of electrons and atoms.
If I focus that sound, I
Mm-hmm.
can go for a long, long distance. It's just like a satellite dish. I'm literally focusing it. If I want to focus it, I could push this sucker very far.
Yeah, I so want to do it. So, what are your plans? What are the next steps with it?
But I'm sorry, say that again.
What are your plans for now? What are the next steps for that setup?
So the next plan is I need to create another field, and I need to hit it with a DC flyback.
Okay.
And once I do, then we're going to start pushing in extra energy into it to amplify it.
Okay.
So it doesn't seem like it, but if I put it in the correct resonance through all of it, and then I shove that DC field right through it, we're going to amplify the living daylights out of it.
That's true. That's true. So the output of the flyback is a pulse DC. Do you need a cleaner DC? Like a flat line DC?
No, I could change it by the capacitors that I put into it. You see, that's where a lot of people don't understand some of this. If I change the capacitors and I just ran my ZDS with my Tesla coil capacitors, my frequency goes up to 200 kilohertz.
Wow.
Now, if I put another capacitor in there or one less, I can adjust it. Now I take Ian's cat bank. I can now adjust my DC capacitance level to match anything I wanted to. You see, the gravity flyer works on beat frequency, so it changes everything for you.
Right.
This right here doesn't, so I would need to change that. And that's pretty easy with the capacitors. We just change it. A lot of people don't know that. I'll show you this just so I can show you one part. Okay.
Sure. Yeah.
Because I just want you to see the energy exchange in it.
Let's see if we can get our Tesla coil spark up a little bit. And there it is. Pretty clear. Tesla coil is on, so you can see that. Now I want you to focus in right here. That's my high voltage. It's on. Now I'm going to turn my Tesla coil up, and I'm going to get it right in the range of 30 volts to go in. You see that right there? That little bit of sparkage is going on right there now. The Tesla coil is interacting with my high voltage coil. Now I don't have anything connected to anything. There are no wires here that are touching the frame. Don't know if it's leakage from the white wire there. I doubt it. But it's the Tesla.
So, by the way, that actually will improve once you set things up right.
Yeah.
But what the cool thing was is you got to see that it started sparking where it wasn't sparking before,
Mm-hmm.
which means the fields are interacting. Now,
Yeah. Yes.
now that I know the two field types that interact, it's now not hard to pull it off if I put everything in cavitation in a mica cylinder.
Hmm.
Now everything is forced to hold in. It can't go out. That field cannot go anywhere outward.
Right.
I'm now concentrating it. Okay. I'm now creating a massive ball of energy inside of a mica container.
Yeah.
That's the thing. So when I talk about a field flip,
Mhm.
now all I need to do is run my DC high voltage to create the flip.
I
I
see.
don't, you see, so you got to take those windings off the can and move them out.
Right.
Now all I need to do is put in the DC high voltage and I've created the flip naturally.
Mhm.
You see what I'm saying? I
Yeah.
don't have to have them real close and have it that way all the time. So the idea is simple. I'm breaking it, putting it in a lot of power when I hit the gas on my car.
Mhm.
It then has a ton more energy into it. It drives into a cap bank. That cap bank is now rectified to DC. Now it drives the motor. But when I let off the gas, and that electric motor drives it. So when I let off the gas at that point, now it goes back to just charging it, but it doesn't charge it in your normal field. It charges through the radiant energy field. So it's negative energy charging.
Yeah.
Okay. That cap bank's going to discharge no matter what. It doesn't care if it's radiant energy or any kind of energy. It's going to fill up and it's going to spark and it's going to make a giant pop as soon as you put your screwdriver across it.
Wow.
It does not care how you fill it.
Interesting.
So,
And so,
that's
Mhm.
sorry. That's the understanding of Edwin Gray. That's what he did. And it was Tesla, by the way, Tesla's patent
Uh-huh.
that showed radiant energy. And he said specifically in it how he flipped the field in
Mhm.
order to put it into a cap bank to run motors.
It's incredible. Tesla invented the motors, the AC motor.
Tesla invented just about everything. It's all right there in the patents. It was
Yeah.
so
Yeah.
simple to find once you figured out what he was doing.
Uh-huh.
It was easy to find. Like it was ridiculously easy to find.
It's people go to college and they just get funneled into this one way of thinking when there's all these patents full of nuggets in Tesla's patents that they can innovate. And I think you're onto something. How would you construct this mica encasement, or what would you call it?
Well, I found them already at AliExpress. They make tubes
How big? How big are the tubes?
up to 4-inch diameter.
Oh wow, that's big. Pure
Yeah,
mica?
yeah, that's all I needed.
What?
And they also have different materials that they put the mica into, so we can always try something else.
Uh-huh.
That's what I saw. So check it out. Here's the Tesla patent I was looking at right here.
Do you have the number or the name? It's hard to see.
Yeah, let me zoom it in.
Okay.
Apparatus for utilization of radiant energy. Patent number 685957. This thing
Awesome.
was patented November 5th, 1901.
Sounds good.
So there's a guy, by the way, who reads it on his channel.
Uh-huh.
Give me 1 second and I will pull it up for you and drop it in the description. Because it's he did a really good job. And you guys will probably all enjoy it.
Hey
And
guys, a like and subscribe would be awesome. Appreciate it.
so there you go. I just dropped it right here in the description. You
Awesome.
guys copy that. Watch this channel on this patent. And you could just sit back in your workshop and let it play. And it's awesome.
Yeah.
But yeah. It's seriously crazy exactly how he knew everything and how it worked.
That's incredible. There's some smart people out there doing stuff with Tesla's inventions. We just all need to band together. We need to, and under your leadership, Nathan, you are going to build a giant band of like-minded people who are going to do big things.
Everybody has something to share, man. And I built this platform with Ben so that we can have everybody share. That's what we did. And Gerald comes in, man, and Gerald's awesome too. He built this thing with us, and as soon as he gets back, man, he's gonna rock this thing way beyond the rest of us, because I don't think people realize just how far ahead he is. Like,
we know he's just not showing his hand.
Yeah, he is. Like, I can't even describe how many light years ahead of us he is.
Yeah.
So, yeah, I can't wait till Drunk gets back, because especially with the stuff that I'm doing, he has all of it. So,
be awesome.
Ben, you there?
Oh, yeah. Yep. Here we go.
Can you turn the volume up on your mic?
I have to put my mouth closer. I don't know. It's been wonky lately. I think there's a setting here on the bottom. Let me see. Oh, there we go. No.
It is a cool looking mic.
Yeah, I thought there was another knob on here somewhere. Oh well, I'll mess with it later. As long as I keep it close to my mouth, that should be. Does that work?
I can hear you good now.
Yeah.
Okay. Yeah, it's something to do with the settings, I think. Anyways, I have some important updates. All the parts for the Lightning Thief prototypes are going to be here soon. With an interesting addition for my testing. Piezoelectric transducer is coming, the exact one that Mike is using, the 28 kilohertz, because as best as I could see, that's around the range 20 to 30 kilohertz that my Lightning Thief and Mark I coil are using. So that's going to be exciting to test with. But for those of you who aren't familiar, what is the Lightning Thief? Well, it's the prototypes I'm going to be sending out to the team of the Lightning Thief is a device that's going to be able to utilize any bifilar coil, theoretically, to tune your coil and get some usable work out of it. I've been utilizing it as a highly efficient lamp and living room light. Here, let me actually present this, because I have a couple of images. But the micro vortex coil that I recently wound will need some adjustments. So if this works, I'll need to adjust the resistance and play around the potentiometer, to see if I can get anything usable out of it. If this coil ends up working, though... Oh, give me 1 second. Something's going off here.
Look at that. You see that,
all
Sean?
right. Yeah. Sorry about that. So, if this ends up working for us, this is going to be about the size of the coil that I'm going to include with the green machine, which has been delayed. I'm probably not going to be able to put that out to you guys till 2026. But the prototypes for the Lightning Thief should be complete within the next month. There'll be 6 of them that I can do for now, and then I'll work on more later. but they'll include many features for you guys, including banana sockets. Let me actually stop this real quick, and I'll show you.
See, banana sockets?
Yes, banana plugs, sockets. So this is going to be very important because
on your multimeter.
Oh,
yes, exactly. So here's
about bananas.
yeah, banana. So here's the earlier concept. I don't know if I'm gonna keep the plastic around it. I might do something more sleek, like this. But the purpose of this is so that you can easily plug in your potentiometer to the socket here, and it'll or your multimeter to the socket, and this is going to be wired up to your potentiometer. And what this is going to be able to do is when you have this in tune, you adjust your potentiometer with your coil, and once it's ringing, and you see the neon lamp indicator light up, this you plug in your multimeter, and this will tell you the exact ohms and resistance that you'll need to replace that potentiometer to keep it permanently in tune. So that's going to be a very important feature. I wanted to streamline this and make it all easy easy to use as possible, just so it's a tool and not something you're working against.
Yeah, indeed.
Right, so it's going to be hopefully, if it works out, it'll be very convenient for you guys, and you'll be able to modify it and upgrade it, because there will be many features, as I've said, including the board will be easily swappable components. So you can easily disconnect wires, replace burnt out components, or even upgrade and modify for your customized coils. Your coils might have specific requirements. And it'll also have this toggle switch for you guys to easily toggle on between closed circuit and open circuit method.
So it's going to be a finished build, not a prototype.
Well, it's still considered a prototype because I still want you guys to test it out and see if there are any kinks that we can work out before we roll it out to the consumer. Again, it's all open source. If you want to go and build this thing yourself, you can. But I wanted to, put out some things in the coil shop that are easily accessible for people who aren't, too keen on the do-it-yourself aspect. But we do, yes, and we do have do-it-yourself things coming soon that I'll get into in a second. But this is just, going to be for lighting and heating. Hopefully, I'll be doing the heating testing soon, later this month. But yeah, hopefully it'll work for you guys, and it'll be something that you can utilize for your own projects.
Do you mind if I ask, are you going to use it to power some heating element that then is going to be blown out from a fan?
I'm not quite sure how we're exactly going to do the heating at this moment, but I have theories. Since I haven't actually tested it, I only have theories, and from theories based on what I've seen other people do specifically, and that's using soft iron in the center of the coil while it's using a closed circuit method, and directing some of that energy to the soft iron metal, and it supposedly will heat up,
Sure. Sounds like it will.
So yeah, there's some options there. I'm kind of excited to do that because, as you know, it's very cold here where I am. And heating is expensive. The unit that I have is not bad, but it's really, really expensive to run. So, if I can keep it off and just, warm the bedroom with this small unit and a 12-volt battery, and that's, probably will run all day, if not longer, because, again, the Lightning Thief will run the battery down to literally nothing. So you gotta watch that. It will just keep on going and going and going.
Just real quick, there's a good idea in the chat. Mr. Lania says try nichrome wire. I have a spool of nicro wire, and it's basically you just run electricity through it, and it efficiently puts out heat.
Oh, that's interesting.
It's not expensive.
I will have to take.
Again.
Microme?
Nichrome wire.
Nichrome. I'll have to write that down. That is awesome.
Nichrome.
Oh, I see it right there. Nice. Thank
And
you,
then what does
Mr.
it do?
Lanius.
They use it for wire wound resistors because it's basically a wire that has high resistance, but you can use it for heating. Just wind it in a coil, run a little current through it, and it'll heat up like a heater.
That's awesome. Yeah, we're definitely gonna have to order some of that. I just have
it the way you want.
Yeah, that's. I mean, you can make a coil out of it too, right? I assume.
Yeah. Oh yeah.
So yeah, maybe make the coil itself out of that wire, and I don't know. There's a lot of ideas you can play around with there, you know, or run a wire in the same pattern along with the coil. You know, I don't know. That's really awesome though. That's a really good note, something to note there for the testing, because honestly, I don't have a lot of ideas in that realm. I've got a couple of ideas based on what other people have done, but how I'm actually going to utilize this for practical, heating for myself, that's always been a big question. What's the best method to do it? Should I heat up water in a radiator and do it that way? Or no, I don't know. We'll try a bunch of different stuff. But we just have two more quick updates, because I know we've been going over a little bit, and just some really quick updates that are really, really cool. Some new additions to the Coil Kits Lab Shop. So the Coil Kits Lab Shop is the lab shop that will be providing some of these devices to the consumer market soon, later this year. But a new addition is Michel's Tesla lamp, which all of this is open source and in the public domain. We will soon be providing all of the 3D files. I think that Michel already has some of the 3D files for the Tesla lamp already on his channel. I'll provide the links at the end of my presentation, but I've been calling this Project Lumen, or just Lumen lamp, as in Lumin, not En, as in luminiferous aether. So yes, I don't really have a better name at the moment. If anybody has any suggestions, we're still open to changing the name, Michelle and I. But this is going to be a really cool device here. Let me change and show you. So he just sent me this entire kit. He sent me an entire one and one for us to build live on stream, which we will do soon. Yes, and it's able to utilize swappable coils. Michel included two for me to mess with, the Caduceus coil and the Tesla Fusion pancake coil.
Nice.
Yes, so you can swap it out. You can see the two coils right here.
Wow, works of art.
Yes, and they're two Michel original designs based off of previous coil winding patterns, but I believe this is original because he transcribed them to the pancake design. He included two of them for me to mess with. So, this is really, really, really awesome that Michel did this. He's been killing it, absolutely killing it when it comes to knocking out some of these devices and like the PCB boards for the Lightning Thief. He modified the ABHA excitation circuit so it would work with our coils easily. That was all him. He made all these components that I'm trying to put together and make available for you guys on our lab shop for those who just want to buy it, and don't want to spend time putting it together, or you want to buy the do-it-yourself kit. So you don't have a 3D printer and you can't print these components yourself. But yeah, it's going to be really awesome. I highly suggest subscribing to Michel's channel. It's called Michel's Bench, and my channel as well, Beneficence TV. I'm going to put those in the chat right now while I go over the final chapter in this presentation, which is Michel's most recent discovery, which is really cool.
Hey, Ben, real quick, on this board, can we order that right now?
You talking about this right here? I believe he has the 3D printed files available if you want to print it, and everything is like this is just the excitation circuit right here. So everything is open source already, but in terms of having it prepared, we don't have stock yet for the public. I want to make sure I have some stock before we go live with this stuff on the market, just so it's not like people are waiting for it. I have taken reservations for the Lightning Thief and the Green Machine, but I don't want to start taking reservations for all these things and start over-promising. I want to take it one step at a time. So we're going to kick it out with the Lightning Thief. This is all open source, by the way. So in the meantime, if you want to print this out yourself, and if you have the means to buy all the components, it's all in the public domain. You can wind it yourself. We have tutorials online to show you to do that. I'm going to show you how to do that live on stream. But yeah, in terms of having it available for you to just straight up buy, it's not available quite yet. But this, I'm sure we're going to be able to do this a little bit faster since it's all ready to go. We might be able to have this out at the end of 2025 as well. So,
well, if I'll say this, if you provide the link for like a PCB way or something like that,
yes. So yes, you can. And on Michelle's channel, you'll be able to get all of that information, how to wind the coil, the details of the circuit and all that stuff. And it's, like I said, it's basically the Jewel Thief circuit that we've been using. So it's just utilizing these different swappable coils that he designed. And you can go on there. There's a couple tutorials on how to wind them. I'm going to be going through in more detail because he kind of did like a very fast job at explaining it. I'm going to go through and live stream in more detail, and we'll wind one together, because it'll be a learning process for me as well, I'm sure. Yeah, so, but I'll post the link right now for Michelle's bench. And as well, I'll post my link for my channel if anybody's interested in keeping up to date.
Absolutely.
So Ben, can you share a little bit about that interestingly wound coil behind the light bulb? The flat pancake coil?
Give me 1 second. I got to post these links real quick. The first link I posted was for Michelle's bench. That's Michelle's channel on YouTube. And then the second link I'm posting is for my channel. So if you guys want to stay up to date on all the new updates regarding these awesome devices, these two channels are the channels you're going to want to have to subscribe to. So we really appreciate all the love and support thus far. Sorry, I lost my train of thought there. You said, what was your question?
So there's a green circular coil in the back. It's green and it has the copper wire. Can you explain a little bit about what that coil does?
The Tesla fusion coil. So I'm not quite sure what this is supposed to do, honestly, but I know that the Tesla fusion coil gets a little bit more efficiency compared to the Caduceus coil. So I can give you some of the statistics or the data that was pulled. Give me 1 second, I'll pull it up. I thought I had it up here.
You have the test. Is it a patent?
No, this is all in the public domain.
Sure, his patents are in the public domain. I'm just curious, this Tesla, what would you call it again? Vortex?
The Tesla fusion coil? So
Fusion.
that, I'm not too familiar on this, honestly. This is Michelle's design.
I see.
Yeah, like you'd have to really ask him, and I'll probably get more updates on that as I do, as I talk to him more and do more experiments with this. But as I understand it, this one gets a little bit more efficiency compared to the straight up Caduceus coil.
So hold on. If I'm not mistaken, it's a bifilar coil with the exact number of windings, or exact distance of wire. from one coil to the next. So they're set to resonate together, Sean.
Yes, I believe you. Yeah, that's right. No, you're right. You're right, Nathan. That's exactly what it is. Because I couldn't remember exactly what the difference was. These are all new to me. He
really
just came out of, yeah, he comes up with this stuff out of thin air, and I have to keep up, you know. But yeah, this is really cool because, so he said that he was running it about an hour at a time per night, and it made a good night lamp. And off this 9-volt battery, he said it projections were about, it would last, I think, 60 hours. So that's incredible. Like, I've never gotten anything to last that long off a 9-volt battery.
Yeah. Are the 3D print files on his page?
I believe so. If they're not, we're gonna be able. We'll release them very soon if they're not already. So I know that he intended to put them on one of his videos. I didn't honestly check. So if it's not on one of his videos in the description, then you know, just let me know and I'll get with him and we'll put it on one of the new videos we come out with.
Hey Ben, I'm curious, what is the actual amount of energy he's pulling on this thing? It'd be interesting to see his calculation of how much energy he uses to light the light bulb versus the wattage of the light bulb. You know what I mean? Like,
yeah, I had some of the data.
Like, I had some of the efficiency.
I had some of the data written down. I'm trying to find what he said. I don't know what the actual efficiency is because he doesn't have a lumen counter or any way to gauge exactly what the brightness is. But we can tell you, like, give me 1 second. Let me pull up the data because he was telling us exactly how much current was being pulled through the system compared one coil versus the other. And I had it written down. I think I accidentally deleted it.
I could have used these about a week ago, Ben. They shut off all the power in our area, and a little 9-volt battery would have kept the whole bathroom lit up.
Yes.
In the dark.
Yes, that's exactly what we want to get these out there to the public for. You know, like if the energy grid fails us, we need to have a cheap, affordable backup solution. At least that's where I started. I needed one. So yeah, no, definitely. And the Lightning Thief should be able to do that too with, you know, you just hook a coil up to it, but this will be a lot more convenient because it's compact. You know, it's nice, compact. You can put it right in the bathroom or, you know, in your bedroom, or if you have to, you know, light up your desk or work area, you know, in an emergency situation, or you just want to save power. You don't want to turn on the freaking light. That's what I do. I turn off all the lights and turn on my Joe Thief lamp, the Lightning Thief device.
Yeah, it's basically tripling the hours of like a flashlight and
right.
On a battery.
Most people just mistake it for an amplifier. It's not just an amplifier. It's not there just to amplify your voltage. It's there to capture the back EMF, and so you can utilize it. It's an oscillation circuit, you know? So this is exactly what we're doing, and it's recycling the energy very efficiently, extremely efficiently.
He should look up like an old school Tesla design and make the 3D print look like it. So it looks like a sculpture in your bathroom. You know what I mean?
Right.
You just flip it on when you need it. That'd be awesome.
Yeah. Well, I was thinking about getting like a small, like, you know, okay, so you know the image of Tesla where he's sitting in front of the big pancake coil? Mm-hmm. I was thinking about getting like a little 3D printed Tesla sitting down like in front here somewhere.
You gotta have a little bin. You gotta put a little bin on it. The hard hat.
The hard hat. That would be cool, yeah.
You know,
or we'll have it swappable for each member of the team. How's that?
That's so awesome.
But we have to have the bobblehead. We'll have a bobblehead. So I haven't gotten this working quite yet. I mean, it powers on sometimes. So I was messing with it for a few minutes before we went live. So, but I haven't gotten it working yet. So I'll be working on that. That's what I'll be working on. But that's all I got for you guys today. Oh, no, wait. I'm sorry. I forgot. I totally forgot the last part. This is the best part. How could I forget this part? What is this? Hold on, let me close this. So, what is this? What is this that Michelle sent me? I wonder. What do you guys think this is?
Hopefully, it's appropriate for the channel.
I'll give you. Well, I'll give you a little peek under the skirt. Ooh. Okay, so we're gonna open that up in a second. But this is Michelle's recent discovery, and I'll read exactly what he wrote to me. I have made a small discovery that I'm sure you lot will love to play with. Two North Pole magnets glued on the North Pole with a single coil around act as a transformer and amplify the voltage from 300 millivolts to 10 volts under load. Same current input, so it's not an inductor and it's not a transformer. It's not a transformer, what the heck? It seems that the magnet is producing work for free. Also, with the same current input and the magnet connected in series, I can at least double the light brightness output of this, lamp that he sent me at no cost to the current, no extra current input. So this is cool. We're going to open this up right now. This is his most recent discovery, and this is something I'm really excited to mess with. And probably one of the reasons why Customs opened the package and kind of spilled some of the components. That's why some of them were loose there. Yeah, they wanted to get a good peek at what the hell this was.
Yeah, they do that all the time.
But luckily, most of it was intact. So
nice. So is it a time machine?
I don't know. This could be anything, guys. We're gonna only time and testing will tell.
Michelle has it on his channel.
Only time and testing will tell. Yeah, no, this is really cool.
Sit on it and plug it into the socket.
We're gonna fry me and find out. Is that what's going on? We've de-escalated to frying me and finding out.
John says it's the flux capacitor.
I know, it's so cool. We're gonna have so much fun testing with these new devices, guys, and I'm gonna work really hard, even though I'm on a shoestring budget, to put this stuff out there for you guys. This is gonna be really exciting, and the piezoelectric transducer is gonna be here tomorrow, so we might see for Free Energy Fridays something new.
Nice.
Yeah, very cool. Well, it's 7:30. Wow. Oh, it's Chicago time. It's that
about
time.
that time, huh, Sean?
Yes, sir.
All right, guys. I'm going to give you guys both a hand. You guys did great today.
Yeah.
Thank you, and a hand to Michelle. Yes.
Yes, very much so.
Great job, Nathan. Yeah, Michelle. Awesome. And the chat.
Yeah.
And the chat, yes.
We love the chat.
The most vital member of our team is the chat.
Right.
All right. Well,
go ahead, Sean.
Take care, guys. Love you all, and I'll see you in the next one. Bye now.
Love you too, Sean. Have a good night, everybody. Time for me to hit the old dusty trail.
All right, guys. Not a problem. I want to go over Jarvis's. He has a cool video. I wanted to go over, you know what I mean, the next time we're on. And he has a lot of math in it, and I wanted to check out before I showed it. So,
is he going to come on the show with us, too?
No. He did a video earlier on his channel.
We should try to get him on the show.
Yeah, he had like, I don't want to say it. He had some problems with, they kept flying over his house with those drones and shutting off his internet last time he was on. It was like really bad. So.
Well, we'll see if we can try to get him on sometime soon. That would be really awesome to get him back.
Yeah, I think we'll show it, Friday if it's okay with Mike when we do it. But yeah, I'd like to do that. Or else I'll show it with Joe on Saturday.
Oh, yeah. Sounds good.
Yeah. Cool. Well, hold on. Does he say you'll jump on? If you're
He'll jump
available
on?
to, I'll send you the invite right now and I'll hang out a little longer.
Nice.
So give me a second. Let me send it to his Facebook. Oops. And pushing the wrong buttons here. By the way, real quick, I'll show you. Hey, said not now. Okay. I tried. Everybody likes it when you come on, man.
It's like overtime or encore.
That's right. All right, I want to show this real quick, Ben, before we take off.
No, you're good.
Oh, that wasn't the right one. Hold on.
That chicken background. Oh my God.
This is a great tube right here, guys. Just so I gave it to you in this thing so you'd understand it. I remember I told you about the perforated holes, the rod down the center, it's pushing out the energy. It's pretty easy to understand. So if you guys wanted to look it up, there it is. I don't know if I can zoom in on this one. I don't think I can, but anyway, I'll put it up in my
Make like a
Patreon
community.
and stuff.
Yeah, make a community post on YouTube too, so we can get the
that'll do.
picture.
Community post
Yeah.
on YouTube. There you go. Hey guys, just to let you know, we need one more member to get to number 20, and then we'll be able to add Sean here in the bottom right hand corner. And that way you can throw up the Sean when you guys get into the chat next time.
Oh, we're about to unlock Sean? Nice.
Yeah, that's right.
This is exciting.
Yeah. Keep unlocking new things, man. Just some fun adventures here. So, yeah, that's pretty cool. And then that's pretty much it. That's all I got for you guys. So we'll be on with Mike on Friday, right?
Yeah,
Cool.
for Free Energy Fridays.
Free Andy Friday, right on. All right, guys, have a great night. Thank you, everybody in the chat. I really do appreciate it. Thank you, Ben. Thank you, Sean, for presenting tonight. I really do appreciate it. With that, thank you very much.
Yeah, thanks, guys. Thanks, Nathan. Appreciate you all. All right.
All right, Ben, we're out.
Oh, I just cut. Yeah, so they heard you say, all right, Ben, we're